Alright, welcome. This is the module 10, Reviewsheet Solutions. Here we have part 1. A. The scatter part below here shows the relationship between the week since a movie has been released and the total rentals of the movie per week. Which statement correctly describes the relationship? Okay, first of all, it says the relationship between the variables is linear. Let's see if it's linear or not. You should see that I could draw a line. Okay, the line of best fit does exist because the points here are very close together and they look like it's going down. That's why I drew an arrow that is straight going down. So the fact that I can draw a line and this line fairly describes this scatter plot, I can say that the relationship between the variable is linear. Second, the fact that this line has a negative slope, I can say that the relationship between the variable is also negative. Okay, the line of best fit will pass through the origin. The origin right here is referred to the point 0, 0. It is never going to touch 0, 0. It is very far away. So we would say that this one is incorrect. Here it would say that the slope of the line of best fit is positive. That is wrong. It has a negative slope. The reason why it has a negative slope is if you draw that person is walking down. The fact that it's a negative slope, we would say there is a negative association between the variable and the line of best fit does have a negative slope. B. The scatter plot here shows the relationship between the number of days since a flower seed was planted and the height of that plant. Which statement correctly describes the relationship? This relationship is nonlinear. Okay, yes, it does curve. Why does it curve? Because the first couple of days here, okay, it doesn't grow linearly. Okay, here it is very flat. So that is correct. The relationship is nonlinear. Is there a positive association between the variables? Yes. You could see that it is going positive. Okay, if you draw the guy, it's right here. He's walking up. Okay, we would say that there is a slope. Next, the slope of the line of best fit is negative. That is wrong. Ooh, I didn't cross this out, did I? Yep, it was supposed to be crossed out. The slope of the line of best fit is negative. It is a positive slope. Okay, so that is wrong. The line of best fit does pass through origin. The origin is right here. Okay, this is the origin at 0, 0, if you don't know that. And it does pass through 0, 0. And the relationship between the variables is negative. That is wrong because, again, it has a positive relationship. So there should be a positive relationship. Okay, that was what was crossed out. Okay, so the only true answers is the relationship is nonlinear. There is a positive association because there is a positive slope. And the line of best fit will pass through the origin because at the start, the height of the plant is 0. Okay, part 2. The 8th graders at Southridge Tech Middle School attend the winter dance. The data is summarized in the two-way table. Okay. Convert the table to represent it as a percentage of the whole. Of the whole means, in this case, you're going to divide by 400 because 400 was the total. So every single number here is going to be multiplied by 400. The first one, okay, if you plug in your calculator, 50 divided by 400. Oh, I gave you the middle one first for some reason. Okay, 50 divided by 400 is 12.5%. 100 divided by 400 is 25%. 150 divided by 400 is 37.5%. Remember, once you plug this into your calculator, you're going to get it in decimal. So, if you put 500, let me show you. Let's see if I can pull up decimals. Give me a second here. Okay, so I have decimals up. So let me show you the first one, right? So 500. Oh, sorry, it was 50 divided by 400. Nope, nope. 50 divided by 400. Okay, and you're gonna see it's 0.125. What you have to do with that 0.125 is that you have to multiply it by 100, and it's going to get you into its percentage, which is 12.5. Okay, let's do the female that attended the dance. 230 divided by 400. That's what it looks like in decimal form. So now I type in its decimal form, 0.575, and I multiply that by 100. That's how I got the 57.5%. Okay, so that is how you go from percentage to that's how you go from decimals to percentage. Oh man, I'm still sick. Okay, that's it. This problem just asks you to convert raw data into percentages into its relative frequency table. Okay. All right, part 3. This is actually a very difficult question, so please pay attention. The random groups of students were surveyed at South Regis Tech Middle School on where they get their entertainment. The results are shown in the table below. Isabella looks at the data and concludes that the 8th graders are more likely than the 7th graders to get their entertainment from the internet than TV because more 8th graders respond than 7th graders. Okay, explain whether or not Isabella's correct. Include all your necessary work to support your answers. Okay, so there's two answers. There's the wrong answer and there's the correct answer. Your intuition is actually going to give you the wrong answer. What you're going to do is this. You're going to look at these two numbers and you're like, well, look at the internet. It's 49 for the 7th graders and 68 for the 8th graders. So you would say, hey, both grades are more likely to get their entertainment from the internet than the TV because the value of the internet is greater than the TV for both grades. Makes sense. 49 is bigger than 13 for the 7th graders, and 68 is bigger than 20 for the 8th graders. But here's the real solution. First of all, you have to see what the total 7th graders are. There's 62 of them. The total 8th graders here are 88 of them. Okay, I added. The 7th graders, I got 13 plus 49, got to me 62 total 7th graders. 20 plus 68 gets me a total of 88 total 8th graders. Now, I get the internet from dividing it by the total. So the first one is divided by 62, and the second one is divided by 88. Some of you think, did I make a mistake? 49 divided by 62. I typed this in by mistake. Hold on. Hold on. Hold on. I typed this in by mistake. It should be what? 62? Look. Yeah, it's still 79%. Okay. I typed it in wrong. If you're doing your calculator, it's 7.72 roughly. 68 divided by 88, that gets me 70.77. Okay, in percentage form, it looks like that: 79% and 77%. You see, here's the issue. Okay, you would say that Isabella is actually wrong. Okay, the 8th graders have actually a lower percentage than the 7th graders because look, the 8th graders are 79%. The 7th graders are at 79% that they prefer internet. 8th graders are at 77% prefer internet over TV. So here, Isabella is actually wrong because you could actually conclude that the 7th graders are more likely to get their entertainment from internet than TV because their percentage is actually higher. So when you compare things, you want to actually look at a percentage. And here, we actually had to get its percentage by looking at their total, but you're not looking at the total of the school, you're looking at the total of the grade level, right? So this one was of the 7th graders. This is 68 of the 8th graders. That's why they're divided by different values. Okay, so this is the correct answer. Isabella's wrong because it should be that the 7th graders are more likely to get to prefer their entertainment from the internet than TV because they have a higher percentage, okay, of their grade level. All right, part 4. The scatter plot diagram shows final grades and the numbers of absence for students. Looks like it has a pattern going down. Okay, so we have 3 questions. Okay, I'm going to keep coming back to this if you need reference. Okay, what does the graph shows about the relationship between the number of absences and the final grade? Well, it looks like it's going down. Let's see. As the number of absences increases, take a look. Absence increase from 1, 2, 3, 4, 5, 6, 7, and so on and so on. You could see that the final grade drops. Let's see if that's correct. As this goes on, the grade drops. That is correct. The attendance office wants to know the number of absence of a student when the final grade is roughly 65%. So let's take a look. 65% looks like it's right here in the middle of 70 and 60. We can draw a line. Oh, that looks like one. That looks like another one. That looks like it barely missed. So 6 absences and 8 absences. Okay, so 8 absences has a grade roughly at 65%, which is good. Also, 6 absences is also around the same value as well. So you could say 8 absences or 6 absences in this problem, and you would still get the right answer. Now, you assume that the performance of the students is the same. Approximate the student's final grade that has 14 numbers of absences. Okay, I would say the grade should be roughly around 45 to 55% with 14 numbers of absences. If you would like to take a look, I could bring it back. Okay, here, this would be where 11 is. Probably the grade's like right here. This is where 12 is, so it's probably dropped a little bit. This is where 13 is, probably drop a little bit. And 14 right here drops probably a little bit. So you see how it's still roughly around this area of 45% to 55%. It's right here. Okay. Good. So those are your solutions for for the first page. So this was up to part 4. You have to watch the other videos for the other parts. Okay.